Hello everyone and welcome back to the channel. Today I'd like to go over another example, and this time it will be just a simply a beam with a hinge in the middle, and the trickiest part, or the one thing that's different from the other videos, is that there is going to be a force directly applied on the hinge. So without further ado, let's just try to solve this. All right. So first thing we always want to do is identify which reactions we want to solve. All right. And oh, sorry, I forgot to write that question down, but hopefully solve for reactions. That is what we will be doing today. Okay. So first things first, always identify what reactions we need to solve for. So in this case, it is AY because this is a roller. Also, this is a roller, so it's BY, right? There is a hinge or pin, or sometimes it goes by a different name, but we'll call it a pin here, right? And then finally a hinge support here, okay? So the way we want to do it is always just go with our three equations. And from last video, what we learned is that whenever you see this sort of pin here, you can split up the problem and take a moment about that point to kind of solve for the unknowns, all right? So here we do have a little shortcut, but I will just go over the proper way. So imagine that this is C, and this is D, and this is E, and there is 24 kilonewtons going down here, all right? And each at 5 meters, okay? So what we want to do is we want to solve for EY and EX at that point, okay? So let me actually just move this down here so it's easier to see. Okay, so first things first, just do, I'll change my pen color, sum of moments around C, setting counterclockwise as positive as usual. And basically, we just want to solve for EY, all right? So if we take a look at this 24, right? Going, and it wants to rotate the system this way, so it's negative 24 times 5, right? That's the distance from C, and then plus, because EY wants to rotate it this way, therefore it's positive, all right? EY times 10, the distance from C again, okay? And then EX doesn't affect it because it's in line with the hinge, okay? Or the point of rotation, and that's equal to 0. All right, now we just simply plug in 24 times 5 equals 120, so 10 EY equals 120, so EY would just equal 12 kilonewtons going upwards, okay? So then we can just do a simple sum of forces in the y direction equals 0, and we can just solve for CY, right? CY at this point. And since CY is just the sum of forces, it's just EY plus CY equals 24, and because EY is equal to 12, we can conclude that CY is equal to 12 kilonewtons. Now, upon inspection, you might just notice that it is symmetrical, right? So if it's something like this, right? Intuitively speaking, if you just apply load here, right? This point and this point would just simply support the an equal amount of load, right? So that's just an intuitive check, really, right? So we didn't need to go through all of this, but it's good practice to do so, okay? So once we have solved for EY, let me grab a highlighter, EY, we can just simply look at the other half of the beam, okay? And the other half of the beam, I will just copy it just because I am lazy, but feel free to redraw it, or even better, just work on your existing free body diagram. Okay, so here, right? Notice that we did not include the 12 kilonewtons here, and I will go into a bit more detail why. But long story short, actually all you need to know for these problems is that whenever you see this 12 kilonewtons here, right, or any load that's being applied on a hinge itself, you just, when you split up the system, you either add it to one side or you add it to the other side, okay? Don't double it up, all right? Just pick one side and roll with it, okay? So once we have this beam segment, which is A to C, right, we can either solve for AY or BY. Now I'll just solve for BY, because that is the easiest. Actually, it's the same, but we can just solve for BY. All right, so by taking a sum of moments around A, setting counterclockwise equals positive, and that equals to 0, right, we find that AY, we don't need it, BY, so this 10 BY, and this wants to rotate it counterclockwise, so it's positive, minus 15, oh, sorry, and when you split up the system, don't be like me, always remember, always remember that there is these reactions, okay? So if we're splitting it up here, if you imagine this, not a very good drawing, but this is, these are these two segments right here, okay? All you really need to do is, in this case, we assigned CY to be here, so CY also has to be an equal on opposite on the other side, all right? So CY is actually going down this way, okay? Don't forget that, like I did. So once we have, going back to this, we took this distance and BY, we're finding the moment about A, okay? So BY, and then it's 10 plus 5, so that's 15 times 12, right? And that's wanting to spin it clockwise, so it's negative, minus 15 times CY, right? That's the moment caused by CY. And I believe that's all the moments there, so that's equal to 0, okay? Now we know our CY value to be 12, so we can just change that out right now. And we have 10 BY equals 2, 15, and then 12, right? That's just from these two here. So once we have that, we can just simply plug that into our calculator and solve. So 15 times 12 times 2 is equal to 360 divided by 10, so BY equals 36. And why do I feel like I am missing a negative somewhere? So always check the sign conventions. BY wants to spin it this way. This force, and CY wants to spin it this way. No, looks correct to me. Okay. And then finally, we can just do a sum of forces in the Y direction. Now we can just do this for the whole system, or we can just do it for this segment. In this case, I'll just show you that it works for the whole segment, but feel free to do it either way, okay? So once we have our BY values was 36, and then EY is equal to 12, right? We can just inspect it and just look. So 36 from BY minus 12 from this point load at the hinge minus 24, and then plus 12, and then that equals 0. whoops, and then I forgot an AY there, okay? So AY would then equals negative 12 kilonewtons. So that would mean that AY is actually going downwards, okay? So newtons. Okay, so let me just go back and highlight the answers and give you a short recap, all right? So a few things to remember, right? One is that when you are solving a beam problem like this, with a hinge in the middle, always remember that you can just split it up into two. And when you do split it up, always make sure that there is a reaction here that you split up. It doesn't matter if this CY is going up and this one is going down. All that matters is that they are equal and they are opposite, all right? And when you piece it back together in an entire system, right, you basically eliminate these two. These two just cancel out, right, because it's not moving here. So this means that you can just disregard C as an entirety when you're considering the whole system, all right? But you can't do that at the very beginning because you don't have enough equations to kind of solve for all the variables, if that makes sense. All right, so once again, you can split it up as a pen, all right, and then add equal and opposite forces, right, and then you can solve them separately, okay? And when there is a load directly applied at the hinge, make sure you have to either include it on this side or this side when you're splitting it up, but never both. Don't double count, okay? So yeah, that's the end of this video. So I hope this has helped you in some way, and if you're cramming for exams, good luck with that. But yeah, more videos coming soon, and that's it for today. Thank you very much.